Ground is a term used to indicate connecting a component to the vehicle frame or chassis. Current flows from the positive terminal of the battery through a controlling device such as a switch, then through the component. The return path is through the vehicle chassis or frame to complete the circuit and allow the component to operate. Using the vehicle frame in this way simplifies the circuit wiring. A tachometer is used to indicate engine RPM. It is normally connected to the negative terminal of the ignition coil. The pulses from the ignition primary circuit are then used as an input to operate the tachometer. At idle speed, the frequency of the pulse is steady. As the engine speed rises, the frequency of the pulse increases as the tachometer indicates. A tachometric relay uses the same input from the negative side of the ignition coil to ensure the relay operates only when the engine speed is above a specified minimum, say 350 RPM. In this case, it operates as a safety device, ensuring the fuel pump operates only when the engine speed exceeds this figure. The term stoichiometric ratio describes the chemically correct air-fuel ratio necessary to achieve complete combustion of the fuel. It is represented by the Greek letter lambda. The value of the ratio is 14.7 parts of air to 1 part of fuel. By mass, that's 14.7 kilograms of air to each kilogram of fuel. So if lambda equals 1, the air-fuel mixture is at the stoichiometric ratio of 14.7 to 1. If an air-fuel mixture has a higher figure, say 1.03, there is more air in proportion to the fuel than 14.7 to 1, and the mixture is slightly lean. A mixture with a lower lambda value has less air, proportionately, than fuel, and the mixture is slightly rich. The exhaust gas oxygen sensor is also called the lambda sensor, since it can be used to maintain the air-fuel ratio at lambda equal to 1, within very close limits. It can be installed in the exhaust manifold, where it measures the percentage of oxygen in the exhaust gases. A high percentage of oxygen may mean too little fuel is entering the engine, the mixture is too lean, and the lambda is greater than 1. The sensor delivers this information to the ECU, which adjusts the mixture accordingly. Similarly, a low percentage of oxygen may indicate too much fuel is entering the engine, the mixture is too rich, and the lambda is less than 1. A potentiometer is a mechanically variable resistor which, in EFI applications, is normally a film type. It can be linear or circular in construction and has 3 electrical connecting points. 2 are at the ends of the resistor and the third is attached to a center sliding contact, arranged to move across the resistor. A reference voltage is applied to the resistor so that a steady current flows through it. As the center sliding contact moves across the resistor, it measures the voltage at the point it is in contact with, and provides a reference voltage for that position. In automotive applications, the circular form is commonly used as a throttle position sensor, with the center contact attached to the throttle plate. The throttle plate position can then be monitored by the control unit. The density of air is its mass per unit volume. This means a volume of air at high density has a higher mass than the same volume at low density. And if there is a larger mass of air, it will contain proportionally more oxygen. The density of air in the atmosphere changes at different temperatures and altitudes. That means the air that enters an engine at different locations could have very different amounts of oxygen. The amount of oxygen in air directly affects how well it supports combustion, so it can be important in determining an air-fuel ratio for an engine. Pressure and vacuum are terms in everyday use in the automotive industry. Manufacturers recommend a pressure to which tyres need to be inflated, and manifold vacuum is used to operate a brake booster. Gases exert pressure on all bodies they make contact with. This applies also to the air in Earth's atmosphere. Air has mass, and as a result it exerts pressure, called atmospheric pressure, not only on the Earth's surface, but also on all objects on the Earth's surface. Atmospheric pressure varies with altitude, but at sea level it is calculated as 101.3 kilonewtons per square metre, or 101.3 kilopascals. But if this is so, why does a pressure gauge read 0 when it is not in use? This is because the gauge indicates pressure above atmospheric pressure only. This reading is called gauge pressure. If absolute pressure was needed, an absolute pressure gauge would be needed, and it would read 101.3 kilopascals when not in use. Absolute pressure equals gauge pressure plus atmospheric pressure. Readings on an oil pressure gauge or on a tyre gauge should really have 101.3 kilopascals added to them. It is normal practice, however, for the gauge reading alone to be taken as the accepted value. If pressure being measured is below atmospheric, a pressure gauge with its 0 reading is of no value. This is why, for pressures below atmospheric, as in a manifold vacuum or depression, a vacuum gauge is normally used. In a petrol engine, the position of the throttle plate controls the volume of air, or air-fuel mixture, entering the manifold. At idle speed, the pistons draw air away from the manifold at a faster rate than it can pass the throttle plate into the manifold. A high vacuum or a depression exists. At wide open throttle, depending on load, the vacuum is much less, and pressure in the manifold rises, closer to atmospheric. A vacuum gauge can be calibrated in millimeters of mercury, and the scale reads from 0 to 760. The scale is derived from the fact that atmospheric pressure supports a column of mercury 760 millimeters high. This glass tube, closed at one end, is filled with mercury, then inverted in a bowl of mercury. The column of mercury in the tube falls to about 760 millimeters. The space above the mercury is a vacuum, and the atmospheric pressure on the exposed surface of the mercury supports the column. At sea level, atmospheric pressure supports a column of mercury 760 millimeters. But at higher altitude, its height falls, which indicates that atmospheric pressure at that altitude is less. A scale of 0 to 760 millimeters can thus be used to indicate the degree of vacuum or depression that exists below atmospheric pressure. At idle speeds, a vacuum gauge connected to the intake manifold will indicate a reading of approximately 450 to 500 millimeters of mercury, depending on altitude. Some engine management systems signal changes in atmospheric pressure by using a barometric pressure sensor in the ECU. This is because, above sea level, air pressure is reduced. So to maintain correct air-fuel ratio, a vehicle has to reduce the amount of fuel delivered to the engine. Volumetric efficiency compares the volume of air entering a cylinder during intake to the internal volume of the cylinder when the piston is at bottom dead center. It is usually expressed as a percentage. In a naturally aspirated engine, one without forced induction, volumetric efficiency can never be 100%. This is because of the resistance to the airflow that occurs at the carburetor, manifold, and the intake valve. With forced induction, the incoming air is compressed so that a greater volume and mass of air is forced into the cylinder during the intake stroke. That takes the volumetric efficiency to above 100%.